So, hello everyone, my name is João. I'm a software engineer at Red Hat, and I'm thrilled to be here today to talk about a topic that is crucial to the health and performance of Kubernetes applications, but even applications in general, testing observability features. As developers and DevOps engineers, we understand the importance of monitoring our applications, right? That's why we are here, diagnosing issues and ensuring our alerts are accurate and timely. So today we'll delve into how we can achieve this using Prometheus, AlertManagers, and various testing frameworks and libraries. First, a little bit about my work. I'm contributing to the KubeVirt open source project. For those of you that don't know, KubeVirt proposes to allow us to run virtual machines as native workloads on Kubernetes clusters. Nowadays, I'm participating in KubeVirt with most focus on observability features in the project. So, moving forward, I'll present you the agenda. I'll start with how to set up a test environment and what it should look like. Then we'll start to talk a little bit about how to test metrics. From there, how to ensure that our alerts are actionable, relevant, and real. Then how to test these same alerts, and I'll show you a little bit of a demo/showcase. So, starting up on how to set up the test environment. First, let's try to understand what this test environment should look like. Probably most of you already use tools like this, right? A while ago, somebody asked how many of you were using Kubernetes, and most of you were. So these tools are probably very familiar. But the idea here is that we want to simulate conditions that approach our production environments, but in a controlled space, right? Without the risk of causing disruptions to actual users or developers that might be using a dev or a staging environment. That's because in our tests, we want to mess with everything, right? We want to delete resources, create different resources, remove permissions, cause network issues. So, and this is where the concept of a disposable cluster comes into play. These disposable clusters is basically a temporary Kubernetes cluster that you can create just for the purpose of the testing. The beauty of this approach is that you can spin a cluster, you run the test, and you just tear it down once you're done. Most of the times they are really cheap and quick to set up. And we can ensure that we always start the tests with a clean slate. We don't have to worry about any leftover artifacts that we might create from previous tests or weird permission changes that might affect our results. So spinning up these clusters can be achieved with tools like Kind, which means Kubernetes in Docker, Minikube, MicroKatos, or any other that you might know. On KubeVirt, we actually do it a little bit different. We have this really cool tool already, and I personally use it every day because it really simplifies our job. It already comes with everything you might need to test everything, and it creates a cluster. It, for example, has the flag that we just set to deploy everything monitoring related. So it takes a lot of responsibility of thinking about it. But later on the CI and automated tests, we are using full provisioned clusters. But I mean, that's kind of a bonus for more mature projects, right? We are in a stage where we want to be sure that the testing conditions replicate the conditions that we'll face on real clusters. We have a lot of users. Many companies are vendoring this project. So we try to make sure everything is working fine. But as I said, this is a step that we can implement a bit later when the projects are more mature. So let's advance to how to test metrics. Metrics are the base of observability, right? They give us the insights on the behavior of the applications and help us diagnose issues. So we'll try to explore a little bit on how to write the tests for these metrics. Are unit tests enough? Well, I guess this is a dumb question, right? Of course, unit tests are not enough. But in the ideal world, everything will be fully tested. But all of us know that that is not possible. Time is limited. Personal resources are limited. So we can't have everything. So unit tests, yes, are kind of enough, at least in the beginning. In my opinion, I guess the most important part is to first add end-to-end tests for alerts, and then later we can add those same kind of tests for metrics. Usually, most of the alerts already use many of the metrics that we create, so if we make sure that the alerts are working correctly, we'll have some degree of confidence that the metrics too are working correctly, right? So, in these unit tests, what points should we validate? I always suggest to start simple, and most of the times, the simpler things are the ones that in the future end up by saving us the most time. When talking about metrics, it's usually very important to validate that they follow the right naming conventions. If possible, for example, what we use is that we try for the metrics to be prefixed with the component name. We'll see later on an example that I will give that for customers and products with many components, this will help save a lot of time in the future. And we want to add unit tests for functions that might update metrics and validate that after they are executed, the metric is updated to the correct value. As then again, we'll see later on the demo. So let's move on how to ensure that the alerts are actionable, relevant, and real. And I guess this is the main concern about this topic and this presentation, is that we don't want to be flooded by false alarms or even missed critical alerts, right? So we'll try to discuss on how to ensure that the alerts are correctly configured and that they react to the appropriate triggering conditions. I brought this code. This is probably one of the most known codes in the area, and probably many of you already saw it, that every time the pager goes off, I should be able to react with a sense of urgency, and I can only react with a sense of urgency a few times a day before I become fatigued. Actually, yesterday we had a talk by Monica that mentioned this exact same issue. So most companies are facing it, and this just helps show that the problem is real and we need to take action to improve our solutions. And because we need to know that this kind of alerts might actually wake people in the middle of the night, and this is even more important when we produce software for external clients, because we don't know their conditions and we don't know, for example, how many on-duty people they will have and where those people are located. I've worked in a small company before, and we were just 2 people managing the infrastructure, but we had users like all around the world. So if we had a critical alert, one of us had to wake up in the middle of the night. So it better be a real alert, right? And so for alerts, the few bullet points that I have here that they usually should have configured is that they should have an owner, like a contact person that is able to quickly figure out the problem that created the alert, or the process, or the metric it refers to. As in metrics, we should be able to quickly identify the component to which the alert refers to. For example, if you have a Kubernetes operator that is managing resources on IBM Cloud, and we might have the alert triggering that IBM Cloud is not available, if we can quickly identify what the component is responsible for the alert, we can more easily go there and navigate the logs and understand the problem quicker. Also have a summary and a description, and I think these two are pretty straightforward, right? And we should have a severity and a runbook URL, which we'll look in more detail in the next 2 slides. So for the alert severity, we should use at least a small set of defined severities. The ones usually suggested are critical, warning, and info. And this is super useful to distinguish which actions we should perform to sort priorities on the upcoming alerts. When we get a critical alert, usually we will page people. If we get a warning alert, maybe let's just create a ticket to be looked later on in the same day or in the next day. And if you have an info alert that usually don't perform any immediate action, and just create a ticket to be looked at when we have the time. In terms of the alert runbooks, in my opinion, this is very, very important because they serve as a comprehensive guide for owners and operators. And they should provide step-by-step instructions on how to handle a specific problem. If we don't provide these handbooks, usually owners and operators will need to go through documentations or their own personal notes to debug and fix issues. Yeah. So picking up where you left off, I was discussing about the importance of alert runbooks, right? And I was saying that they are very important for owners and operators when they want to get down and try to fix an error that is causing an alert, right? And I was saying that usually when you don't have these kinds of guides and step-by-step tutorials, usually operators will go through documentation or their own personal notes to try to debug and try to fix the issue based on previous experiences or some weird forums on the internet. And usually this ends up wasting valuable time, right? And when we are talking about businesses, losing time almost always equals losing a lot of money. So, and this not to mention that sometimes they even might be forced to rely on just memory, on improvisation, and when that happens, that even might lead to even more errors and mistakes made by them, which might mean even more delays. So, let's move on testing the alerts. As for metrics, the idea is more or less the same, trying to start with simple steps, and because sometimes, again, those steps might save us from a lot of headaches in the future, and we should validate then that each alert includes all the mandatory fields, that each handbook URL link is a valid link and actually points to an existing document, sometimes happened at 404s, and that each alert includes a reference to the origin instance or to the origin pod, and that the alert is obviously triggered when the expected conditions are met. So let's go down to the demo. I need to increase. So basically, starting with metrics, we just have some logic to register our metrics and then to later be able to list all the metrics that our application registers. For these purpose examples, I'm developing a Kubernetes operator called test operator, and for now, I just want a metric about the number of reconcile loops that it's a counter. And I go to my test controller that has a lot of logic here, but basically every time the reconcile loop is called, wherever some actions perform, if you are not using operators, we just increment the reconcile total metric, right? So let's look at our metrics tests, and the idea here is that we want to validate, as I said earlier in the presentation, that we'll try to link the metric to validate every field is present, and in our use case that we want the metric to start with a prefix test operator, so we can later be quicker to understand where the issue comes from. And I have this link here because on KubeVirt, what happened is that in the beginning, there was not much of observability team and not much of concerns about monitoring. And so developers just add metrics as they went and as they thought were needed. And what happened is that when later we tried to enforce the linting, most of these errors actually are already validated by PromLint, but none was being used, so we get this extensive list of metrics that do not match the conventions, and now it's very hard to deprecate them. We need to start about deprecating policy, how many releases to keep them, how to warn users and vendors that these metrics are no longer available. So, as I said, when you start even that in the most simple of ways testing early on, in the future it will save you a lot of headaches. And so moving to the test itself about the update of the metric, we just get the initial value of the reconcile count metric, then we create a new test reconciler, we call the reconcile function, and when we get the value of the metric again, we expect that the value of the metric is equal to the initial value plus 1. It's a very simple, right? The logic is not complicated either. You can test here, for example, when the errors might happen, when the resources are updated. Like every metric, more or less, can be tested in a very simple manner. So, moving forward to rules, let's start, for example, with recording rules. So here we have a set of recording rules related to the operators, and these are rules that probably very simple and most of people might have. The number of pods of the test operator that are running in the cluster and the number of ready pods. This will later be used for operator alerts. As you can see, I have here the test operator down alert. It's using the recording rule. I have all the fields that I mentioned that might be useful: summary, description, the runbook URL, a severity, and yeah. So, and I'm writing the tests for the alerts. Once again, very simple stuff. Let's list the alerts and validate that the alerts are correct. Actually, since we are working a lot with Kubernetes operators, we actually contributed to Operator SDK with a set of observability best practices, and every test that is here, it's recommended on those very best practices. For example, the alert must have a name and it must be in Pascal case format, must have an expression, and let's validate the labels and the annotations. For labels, we just want to validate that it has a severity, and it should be critical, warning, or info, and should have a summary annotation, a description, and a runbook URL. Then again, you're probably thinking, oh, this is very basic, this is super easy to test, but then again, I showed you earlier that developers that are not very concerned about monitoring will not be concerned about these kinds of details, and it will come back to want operators first, and then later on developers themselves. So, and if it's very simple, let's implement it right away. So, now about end-to-end tests. Let's again start with metrics. So basically, before each test, let's just deploy our test operator. Actually, I have here some steps of what I did. Blah, blah, creating the operator, and I built an image, and actually I'm using int in this example, so to create a cluster, and I'm applying the Prometheus manifests to quickly deploy the Prometheus, and then some extra configuration. Here, I just deploy the test operator. On operator SDK projects, it usually means make deploy and passing the image I want to use, and I'll just create a new client. I'll also port forward for the Prometheus services, just executing the port forward command, and I'll create a new client to Prometheus and a new API, and delete any resource that might be created in these very tests. So let's now see how to test that the test operator reconcile count metric is increased. We get the initial value, easy peasy. Then we apply a resource, and let's eventually wait for the metric to be updated, right? Because the resource is creating, Kubernetes is sending the request to the operator, which will then run the function. So eventually, within 1 minute, we should see that the test operator reconcile count was updated and that its current value should be equal to the initial value plus 1. So getting the metric very easy, using Prom API, query, pass the name of the metric, time now. You can put here any more complex query you want, labels, anything, and just check for the values match whatever you are expecting. For the alert tests, first we have a quick test to validate that the runbook that we created actually exists. So here I'm actually testing again that the runbook notation exists, but then most importantly, fetching the URL and checking that it actually returns a 200. I also have here the example of, maybe I don't. An example of a runbook. We have what it means to be facing this alert, fires when no test operator pod is running, the impact of the alert, indicates a failure at level of cluster, blah, 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 functionalities. So, for example, on KubeVirt, for example, if Virt controller is down, virtual machines are basically running while in the cluster and nothing is controlling them. You can delete, create new ones. And the steps to diagnose the issue, how to find how many, for example, deployments you should have, which pods you currently have, and mitigation steps to fix the issue. Going back to the test, then we just add a test to make sure that the alert fires when the expected conditions are met. Basically, if we scale down the deployment to have 0 replicas, we know that eventually, when we get the alert state, we should have an alert state of firing or pending. That we have like this 5-minute delay to trigger the alert, but in our end-to-end tests, if I check that the alert is in a pending state, I'm more than happy to return this as a success because I know that a few minutes from there it will be firing, so it's the same for me. Let's just check how to get the alert state. Very easy again, using Prom API, listing the alerts, and expect to find an alert where the alert name label will be the alert name that we are looking for. And that's basically it. So I just wanted to give one more useful tool. We are not actually using this yet in KubeVirt, but I've used it before, and it's Chaos Mesh. It's really simple to use and really powerful. It without almost no configuration lets you, for example, cause random issues with pods, deleting pods, being terminated out of memory, network issues like adding a lot of latency, dropping packets. So all of these tools are really useful to simulate conditions that might happen on production clusters, right, that we don't have on local clusters. Sometimes we might have nodes that are distributed around different regions or different providers, so we want to add these conditions to the tests. And to wrap up, I just want to say that I focused a lot on it's very simple to add these steps. The tests are really simple, but then again, they will save a lot of time in the future. So now I'll be happy to answer any questions you might have.
So, thank you very much. Sorry for the disruption with the cables. So, nothing is really highly available, so monitoring is important, I guess. Yeah, any questions? There's one.
Thank you for the talk. It's a nice framework for testing, but I have a question. How can I test the alert which measures, for example, that at least 20% of free disk space left on the pod, something like that? Would you need to attach persistent volume in this framework?
Yeah, and in a lot of tests, for example, on KubeVirt, we are creating virtual machines, and it means to create a virtual machine, you create a virtual machine resource, which will have volumes, pods, and a lot of other necessary resources. So you can just go ahead and create any resource you want, right? The idea is that we have like this disposable cluster when we might be free to create whatever we want. So yeah.
Yeah, but I would need to fill that persistent volume with some data to reduce the free disk space and then check the alert, right?
Yeah. And,
yeah, but it sounds complicated. I just don't understand how it works in this framework.
Yeah, one example similar that I might recall right now is that we wanted to test like for virtual machine memory. And basically what we are doing is launching a process that was connecting to the virtual machine and running a lot of no-op operations just to fill up the memory of the virtual machine. So I guess you could do the same if you create like a PVC with a very small size, right? You just create a process that connects to the PVC and just writes whatever in a text file and expect that the alert will be triggered.
Okay, thank you.
But if, like, for example, I would like to be able to confidently say that end-to-end tests on KubeVirt are fairly cool, okay? So try to check there, and you might have some hints of stuff that, and sometimes a bit of hacks that we do to simulate these erroring conditions, right? And if you check there, you surely find some cool stuff. And you can also message me, and I'll be sure to help with some more concrete examples.
Okay, thank you.
Okay, thank you for the presentation. From the example that I saw you had on your slides, you are setting up the cluster. Before each test.
In the code.
Oh, in the code, yeah. So this, my understanding is that it's kind of a costly operation. Like, how fast can you run this end-to-end tests? Like, do you have also parallelization so that you can run multiple tests at the same time in different clusters?
Mm-hmm. So yeah, and this is just a small demo. So deploying the operator every time is not costly, and you'll actually will check that. Check if operator is already deployed, so it doesn't do anything because it's already deployed. But yeah, what was the second part of the question?
How fast do you run them? Like, how long does it take to run one?
Yeah, and that's why I started with unit tests, right? And I find that a lot of times. End-to-end tests for alerts and monitoring stuff actually take longer than the rest of end-to-end tests for other parts of the code that are not related to monitoring, because we might have a lot of waiting time because of Prometheus scrapping and so on. So one of the few things we do is like already the pending state is a very nice addition, and for example, on KubeVirt, I submitted a PR for in the tests to reduce the waiting times. For example, sometimes the alert has a metric that checks the last 5 minutes, so or 1 hour, some stuff like that, right? Because, for example, a warning for iMemory might be in the last hour. So I just go to the Prometheus rules and replace everything with 1 minute. So we are much quicker to trigger the tests. And when I submitted that PR, I reduced the time it takes to run these tests from 2 hours to 40 minutes. So that's the kind of long values we are talking about. Yeah.
Okay, so thanks again.
Yeah. Thank you.